Hey everyone, this is COMPSCI 3, Dr. Tracy, and I'm going to talk about Boolean algebra. So, Boolean algebra operations. The main idea about Boolean algebra operations is that a lot of things that apply to the regular algebra that you're used to is still existent when you're dealing with Boolean numbers, but it's different. So, I'm given an outline here, and I'm going to go over some of this stuff. But I'll go over it using the chapter. So let's talk about Boolean algebra operations. As you know, in a Boolean numerical system, there are only two values, 0 and 1. And since there's only two values, we kind of refer to those as true and false, on and off, yes and no, and you can take on a number of other ways to express them. But when we have elementary algebra, and I'm talking about this stuff you learned in, junior high or something, there's addition, subtraction, multiplication, and division. But in Boolean algebra, we have three operations, and or not. And this is the way that they explain, we can compare to addition, subtraction, multiplication, and division. Okay, if we were to take all of the possible values and we were to multiply them together, this is the answers we get. 0 times 0 is 0. I'm even talking in decimal. We know that's the case. 0 times 1 is 0. 1 times 0 is 0. And 1 times 1 is 1. So that's what this truth table is referring to. For all of the values of x and y, if we multiplied them together, these are our possible outcomes. So we use the symbol. We could also use this symbol right here to designate and. And has the same rules as multiplication in elementary algebra. So and is like multiply. And if we use those operands, those are the results that we come out with. Now, or, if we use the binary operator of or, if this is not true, this is not true, they're both not true. If this is not true, but this is true, then this is true. If this is true and this is not true, then this is true. If these both are true, then it's true. That's the same as addition. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is actually not 1, but it's 1 plus 0 would 2, which is a carry, and we don't have a carry. So, except the 1 plus 1 equals 1. But unlike that, there is no carry in the OR operation, and so that requires more than a simple OR gate. So this is an OR gate. Notice the symbol, because we're going to reuse that symbol as we move forward into logic gates in the next chapter. Okay, so then the third one is not, which is a unary operator, meaning there is only one operator, and it is a complement. So the complement of 0 is 1, and the complement of 1 is 0. And this is the same thing as in elementary algebra, where we just put something and we put a negative in front of it to make it an opposite one. So just like in elementary algebra, there are precedence rules of Boolean algebra. And so the highest is the not, and then we look at the and then we look at the or. And the same is true in elementary algebra, because first we look at the negative, then we look at the multiplication and division, and then we look at the addition and subtraction. So that's how that there is a relationship. Both and or are associative, just like in our regular algebra. And that means that x times parentheses y times z is the very same no matter if you move the parentheses. And the same with addition. The associative property of mathematics is demonstrated in Boolean algebra. And or each have an identity value. That means that when you have an identity value, that any number times 1 is going to be equal to itself. And any number plus 0 is going to be equal to itself. That's its identity. The commutative property says that x times y is the same as y times x, or x plus y is the same as y plus x. And so that's provable as well. So those are all rules that are standard rules for algebra that are also true in Boolean algebra. But there are some Boolean algebra properties that differ from elementary algebra, and that is there is an annulment value. The annulment value says that if I multiply it times any number times 0, it's going to be 0. And if I add 1 to any number, it's going to be 1. That's just this weird little thing that has to happen in Boolean algebra because we don't have a carry function when we're dealing with just a single digit. So and or each have a complement value, and if you multiply them together, they're equal to 0, and if you add them together, they're equal 1. That's the complement. That does not exist in elementary algebra. There's and or are idempotent. That means that if we repeat the application of either one, we're going to get that value. X times X is X. X plus X is X. They're going to be repeated. And they are distributive, which means that going from right to left, we can factor them, and we can use this idempotency property to pull out X plus Y times Z is the same as X plus Y times X plus Z, because X times X is the same as X. And so this is a distributive property that we can bring into play the idempotent property and create factoring. Not shows involution, which means that if we find the not of the not, we get the positive. De Morgan's law, which is expressed here, expresses the duality between the and or operations. So X times not X times Y is equal to not X plus not Y. And so this is the duality and relationship between binary operations and can be expressed through the following truth tables so you can see the proof. Okay, hope this helps. Boolean operations. I will talk to you soon.